Okay, great. Chewong is here as well. Chewong, hi. I hope you're doing good. Oh, all right. So, Romina, you've had a lot of fun playing with the last homework. Yeah, I mean, it was a bit more challenging than the previous homework because, of course, you had more functions to work with, and you really needed to think a little more. Because, as I said, for some questions I didn't really hold your hand. So I'm really glad that you took some time to look at it. Okay, Chewong, no problem. So today we're going to look at the homework together, actually. So I don't know, we might actually spend a little more time than usual, maybe, but we'll see. Because there's something that a new thing that I want to talk about, the ungroup function. But I want to go over the homework with you because I think it's very important. At this point, guys, the what do you call it? The solutions are already uploaded. There's this link that has all the resources. I'm not sure you have it, but if you don't, I'm just going to send it again. Uh, oh wow, Chewon, you took an evening nap, so it's 2 a.m. where you live right now. Wow, I'm always amazed, whenever you come and whenever you join us in our live because 2 a.m. man, that's something. Okay, oh, okay. So there's a little typo here. This is actually supposed to be homework for day 9. That's what you're supposed to name your file, not homework for day 8. So that's something that I need to change and then repost. But yeah, this is essentially already uploaded. So this is where you will find my code, for all the questions that were asked. But I want to go over this with you because I think that it's really important. It's a very important topic. All right, so let's do this. Okay, so I'm going to open the original file. If you have the file open there for you, just go ahead and open it too so that we can read together, or you can just follow me. Okay, but as always, I am going to go ahead and share my live code with you. If you want to copy the code, it's fine if you want to. But again, you have everything in the solutions that I'm posting. Let me open the the project, and of course, okay, these are the solutions. Okay, so I'm going to create a new file, but I'm not going to save it. Okay, I'm not going to save it using the name that I specified. Okay, guys. Oh, Leonard is here. Leonard, my week was great. Thank you very much for asking, and I hope that your week was wonderful as well. Okay, so again, I have the homework on one of my screens, so you can't really see it, but you have the file, so you will be able to follow. But I'm going to read everything anyways, or the most important things I should guess. I should say. All right. So the first thing is definitely to load all our packages. You know what? Let me just go ahead and copy all this, loading the packages and importing the data. I'm just going to, work with this. Okay. And let me go ahead and run everything so that we have all the data in our environment and all the packages loaded up. Okay. So, question number 1, or A. Okay. I'm going to, write it as a comment like that. What is the time zone of the airport of highest altitude and the time zone of the airport of lowest altitude? Now, this was a trick question. The reason why it was a trick question was simply because, using the arrange function is really what you want to use in this case. You don't really, there's nothing to summarize. You want to find the highest for something, a value that does not have to be summarized, right? And the values are already there. The altitude values are there, so we can just do this. Airport, okay, and our range for the highest altitude is going to be descending alt. So that airport is called Telluride, okay, and the altitude is 9,078. And of course, for the next one, the first one was highest and the second one was lowest. So I can just copy and paste this. Oh, I haven't shared my code yet. I'm going to do that. But again, you have all this in the solutions anyways. So, but let me go ahead and share my code anyways. We never know. Some of you might want it, so let me just do it. Okay, perfect. So that was really it for the first question. Okay, so you just needed a range here, you didn't need to summarize everything. And the reason why I asked it is because, it's really important, it's a really great skill to read the question, or, if you know what you want to achieve, you need to be able to break it apart and find out which tool, which of the functions we've learned goes best with the different components of your question. Number two, compute the average airport altitude for each time zone. Okay, well, here we're asking for an average. Okay, the data doesn't have averages, so we will definitely need to summarize in this case, right? Okay, so average airport altitude for each time zone. So we have this column here for time zone, and many of the airports are in the same time zone, right? So what we want to do here is we want to, group by time zone, so T zone like this, and then summarize, right? So because we are grouping by time zone, the summary is going to be for each time zone grouped together. So all the altitudes for each time zones are going to be put together, and then you can do whatever you want on it. So let me call this AVG alt for average altitude, and this is going to be the mean of altitude, and of course if there's any NA, it's not going to take it into account. Okay, so my code is syncing. Okay, so these right here are the average altitudes for each time zone. So this is America. Anchorage is the capital city of Alaska. Okay, you have Chicago, Denver, Los Angeles, and so on and so forth. Okay, now we are going to use this data set to answer some questions. Okay, so one good thing to do here would be maybe to store this data set here in a variable, and then use that variable to answer the questions. So let me just call this average altitude. Okay, that's going to be the name of my data set. Average altitude, like that. Okay, and for the first question, the time zone with which contains the highest average airport altitude. All right, so I can just use the data set that I just created, and I'm going to arrange in descending order average alt, which is the name of the column that I just created. Okay, I want to reorder this. Okay, so Denver, that time zone, has on average the highest altitude, and Denver is in Colorado. Well, it's an entire time zone, right? So this is a place with a lot of mountains, right? It's a place with a lot of mountains. So this kind of makes sense based on the knowledge that we want. Okay, so yeah, it's important, to kind of break down the questions like that. Okay, now the lowest average altitude, I'm just going to remove the descending here, and when I run it, it's actually a time zone which is not named. Okay, but the next one that we know about is Vancouver. Okay, Vancouver is in Canada. Okay, so that's B. And guys, if you have any questions, please do not hesitate to let me know in the chat. There's some sort of lag between what I say and whenever you receive it, but if I see any question, I'll be more than happy to answer. And McNamara, welcome. Guys, I think he wasn't here when I posted a live code. Can you please share the live code with McNamara? Okay, so let's do C. All right, compute the number of airports in each time zone, then find out the time zone with the most airports and the time zone with the least airports. So now, we're looking at counts. We want to count the number of airports for each time zone. So basically, we can have a data set that we call airport count. We have airports, okay? Again, we want it for each time zone. So once again, we're going to group by time zone. And this time around, the summary is count. We want to count how many times, this time zone shows up in the data. Because each row, let me go back to airports. Each row is, each row represents an airport, right? So if a time zone shows up several times, or let's say if a time zone shows up 10 times, it means that there are 10 airports in that time zone. Okay, so this is a case where we can use let's just call it n, the n function, and the n function is for count. If you've taken statistic classes, usually n is for the total number of people in our sample, and that's exactly why we have the n function here. Okay, and I just stored it inside airport. So right now you have the number of airports in each of these time zones. Okay, previously what we did is we calculated the average altitude. Okay, but now we just count the number of elements in each group. Okay, which is the number of airports in this context. Okay, so what is the time zone with the largest number of airports? Okay, so we can just arrange descending order of n. Oh, made a mistake here. Could not find function arrange because I misspelled this. Okay, so that's, you know, that time zone here for New York. That's not the name of a city, that's an entire time zone, you know, from top to bottom, right? With 519 airports. Well, that's a lot. Okay, what about the time zone with the least number of airports? I can just remove the descending order here, and that'll be it. Guys, thank you for posting the code, the link for the live code for McNamara. Okay, so that would be Vancouver with only 2 airports. Okay, the Vancouver time zone. Okay, all right, guys. So again, if you have any questions, please do not hesitate to ask in the chat. All right, so let's look at D. Okay, so D is kind of a little longer. For each time zone, compute the following altitude summary statistics, the maximum. So let me just write the code first. So for each time zone, right, so we'll have to group by time zone again. So what do we need to, what are the summary statistics that we need to compute? Number one, the maximum altitude. So we have the max function, which we talked about last time. I need to give it a name. I'm going to call it max out. Okay. We also want the lowest, right? So the minimum. So I'm going to call it min out. You can call it whatever you want, honestly. It's really up to you. Okay. You know, let's break lines, you know, just to make our code more readable. The next one is the median. Okay, so median is a measure of central tendency too. It's a form of average. Okay, so we have the median function out, and we discard the NA values if there are any, and then the standard deviation. Okay, and I actually, you know, for those who don't know what standard deviation is, I ask you to kind of read a little bit on it because it's a really useful concept. At some point, I'm going to do a introduction to statistics and probability using R, and we will talk about all this. So it's going to be a very practical kind of course, and it really depends on how much time I have. But we'll be learning the stats and the, you know, stats, and then we'll be making it practical by using real world data like we're doing right now, and applying our statistical concepts on it. Okay. Okay, so Romina, I just saw that you posted your code. Did you post your code because you have an issue with it? Because I'm looking at the chat and I don't think you've said anything before that. I just saw the code that you posted. Okay, so let's run this. Oh yeah, that's what I just run. So for each time zone, as you can see, we have the max altitude for each of these time zones, the minimum altitude for each of these time zones, the median altitude, and the standard deviation of altitudes. It's kind of interesting that, you know, for some places the minimum altitude is actually 0. Okay, interesting. Okay, so what are we asking here? Let's call it, I'm going to call it alt for altitude stats because these are different summary statistics. I'm going to save it into alt stats. Okay, so what is the time zone with the highest altitude? We have highest, lowest, and all that for each time zone. So for this one, alt stats, arrange descending order of max out, right? Okay, that's Denver. Okay, which has the highest maximum altitude of all the time zones. You're just sharing. Okay, thank you very much, Romina. Thank you very much. Okay, so of all, you see, these are the max altitudes for each of these time zones, and Denver has the highest of the highest, basically. All right, and does it correspond to your answer in question A? Well, let's check if it was Denver here. Yeah, so out of all, oh no, what we did was, okay, I think I shouldn't even have asked this because question A was asking about average altitudes. Okay, this is something that oh no, I'm actually looking at B. Okay, my bad. This is correct. Okay, so yes, you can see that the highest altitude, okay, overall is from an airport called Telluride, which happens to be in this time zone, right? And this is what is corroborated by this right here. Okay, so as you can see, that's American Denver, and it's the same max altitude. What about the lowest? The lowest airport altitude. So now we want to look at the lowest of the lowest. Okay, so it's going to have to be in min alt. Okay, and this would be Los Angeles. Okay, where the lowest of the lowest is negative 54, so it's below sea level. Okay, let's check here. Yes, sure enough, America, Los Angeles, and the lowest here is negative 54, and that's Imperial Cove, whatever that is, whatever that airport is. Okay, so that was for D. Now the most mountainous terrain, and this really is for the standard deviation. So when we say mountainous terrain, okay, how do we do with the NA in the name of the airport's result? Yes, there's actually nothing that we can do about it. This is a problem with the data. It's not a problem with your code. So if you have an NA, it means not available, okay? So this will have to do, if you're working for a company or something like that, you will need to, get in touch with the provider of the data and ask that provider what is supposed to be there, and then that provider will, likely let you know the problem that was encountered. But NA values are very common in data collection. Okay, it's a very common issue. So at this point, it's not like you can write code to figure out what it is. Okay, of course there are techniques. Maybe you can look at for that NA airport, you may want to look at all the different properties of that airport, and then go to the internet and look for an airport that has these properties and find the name. This is something that you want to do, but it's not like there's a magical code to do that. I hope this makes sense to you, Leonard. Okay, so the most mountainous terrain. So the standard deviation is basically a measure of dispersion. It tells you how far the values in the entire set are from the average, from the mean. Okay, so most mountainous would mean that there are many different, there's a multiplicity of altitudes of airports within that time zone. Okay, so standard deviation is what you want to use for that. Okay, so that would mean that this place is more mountainous. Okay, so yeah, the standard deviation, I want it in descending order because I want the most mountainous, like this. Okay, so look at that, a standard deviation of 1,836 feet. You see, so it simply means that you're welcome, Leonard. It simply means that on average, all airports are 1,836 feet away in terms of altitude, away from the average altitude within that time zone. Okay, so that's pretty big. That's pretty mountainous, And the flattest terrain would mean that there's not too much variation in the altitude. This has the highest variation in altitudes. Okay, but the opposite would be that there's not too much variation in the altitude, which means that basically the terrain is flat. And I hope that this makes sense to you guys. And that would be, okay, NA, we're not really sure, so but that would be Vancouver, okay, with 107 feet as standard deviation from the mean. Okay, so that's D for you. Let's take a quick look at E. Okay, and we have several E's actually. Add two columns to the weather data set, one in which the temperature data is converted to centigrades, and another one in which the wind speed data is converted to kilometers per hour. Okay, and of course, the best thing for us to do would be to save it in a variable. So I'm just going to save it in. Okay, let me just save it in weather 2, something like that. Okay, so this is going to be weather. And because we are trying to add data, we need to use the mutate function. Okay, we need to use the mutate function. All right, so let me just go to the solutions here and just, copy the code. Copy the code for creating these variables. Okay, I actually added some comments and stuff like that. Let me just remove the comments here. You'll be able to see it in the solutions, which are already posted, by the way. Okay, and I have the other stuff here. Okay, so, oops, I closed it. All right, so, convert temperature and wind speed data. All right, so this is how you would convert Fahrenheit, because in the weather data set, the temperature is in Fahrenheit. Okay, so this is how you would convert Fahrenheit to centigrades. Okay, so you subtract 32 from the Fahrenheit data set and you divide it by 1.8. Romina is saying I could do that by looking at variance only as well, right? Yes. Romina, standard deviation and variance are the same, basically. They tell you the same thing. Actually, the standard deviation is the square root of the variance. And as you know, a square root is a monotonic transformation, which means that if A is greater than B, then the square root of A will be greater than the square root of B, right? So if the variance is bigger, the variance of A is bigger than the variance of B, then the standard deviation of A will also be bigger than the standard deviation of B. Okay, so yes, variance and standard deviation are, they will tell you exactly the same thing. Maybe I'm not supposed to say it that way because standard deviation has a better interpretation, okay, but the order is kept basically. So yes, you can look at the variance. All right, so again, this is how you would convert centigrades to Fahrenheit to centigrades. Yes, Chewong, yeah. No. Standard deviation is the square root of variance, Chewon, not variance is the square root of standard deviation. If you want to find variance from standard deviation, you have to square it instead. Okay. All right. So again, this is how you get your temperature, and this is how you get the wind speed in kilometers per hour. Okay. And again, you can just find this on the internet and then apply it to your data. Okay. Thanks. It is just because I came across this article that said the method for flatness calculations is based on variance and then the curve flatness. Oh, okay. Well, I think you're going much deeper. Okay, which makes sense, anyways. It makes sense. It makes sense what you're saying. But again, it's not going to change the final answer. Okay. All right. So for the next one, choose the measurement units of your choice for this. Okay. What is the temperature threshold below which you consider it to be cold? Okay, and I give you a little footnote. I come from a place with tropical climate, so hey, it's pretty warm all year long. What is the wind speed threshold above which you consider it to be windy? Create two new columns with the following specifications. Let the first column be called cold status, with a value called, if you are not in the United States, you would say status, okay? In American English, they say status. So let the first column be called cold status with the value cold if the temperature is below your temperature threshold and not cold otherwise. Okay, let the second column be called windy status and the value windy when the wind speed is above your threshold and not windy otherwise. And I was really glad to see some discussions going on in the homework questions or homework discussions channel. And I think, I saw what you did there. The code was actually right. Okay, so my threshold for cold is 25 degrees Celsius. So you see, I actually, okay, I have a typo here, and this is something that I would need to change in the solutions. Actually, you see, I said temp less than 25, but 25 is really not in Fahrenheit. You know, 25 is already very cold in Fahrenheit. So I need it in degrees, but you see, I'm using the Fahrenheit column here. Okay, so I need to use temp C, which I created previously, and not temp itself. Okay, so I'm going to specify it like that. All right, so that's a typo. That's a mistake that I made. All right, so we talked about the if-else function, and I saw that all of you guys use the if-else function, so that's great. So whenever you have some conditions like that to create new data, you can use if-else. It's wonderful. And sometimes you may actually have more than one condition. In the case when you have more than one condition, you will need to use a different function, because if-else only uses two conditions, true or false. Okay, and that other function is called case when. Okay, and I'm going to teach that function to you. Case underscore when. Okay, so that's for the windy status, and I'm using the correct column here. Wind speed kilometers per hour greater than 16 kilometers per hour. So if it is true, call it windy. If it is not true, then it's not windy. Over here, if this condition is met, then cold. Inside the cold status column, you have the value cold. But if this condition is not met, then the value is going to be not cold. And I stored it inside a variable that I call weather extended. Okay, weather extended. So basically, I'm extending the weather column. All right, so you can see that we have cold status and windy status. Let me go ahead and view weather extended. Oh, view is going to break my code. Let me see if I can remove it. Okay, all right, I was able to remove it. Oof. All right, hey guys, you may want to view it yourself, but just because we are online, I can just make it maybe very small. It's going to be kind of difficult for you guys to see, and I'm sorry about that. Maybe this will do, and I can actually, you know, make this small because we don't use that part very often anyways. The view function came out anyways. All right, so I will need to to redo the live code. Yeah, but you can see that you have cold status. Okay, cold, which makes sense. This is January 1st, right? And windy, not windy, windy, and stuff like that. Okay, January 1st, that's the winter in the United States, and that makes sense. All right, guys, let me just do this quickly. Okay, so Romina is asking a question, but Che Wong asked a question before that. Why are we dividing term C by 1.8? Okay. Yes. So, Che Wong, this is the theory behind it. Let me show you very quickly. All right. So we've got how to convert centigrade or Fahrenheit to centigrade. Okay, so you will see it like that, but you see it's a linear relationship. No, it's actually not quite a linear relationship. There's a formula for it. You may think that it's like what you just saw, but this is basically how to do this. So this is how you convert centigrades to Fahrenheit, and yeah, I think the relationship is non-linear, so you can just multiply it by something, I think. Fahrenheit. I want the formula. Yeah, so that's basically how to do it. Okay, that's basically how to do it. And hey, we can check it since we have R open. I want to check very quickly if the relationship is linear. So let me call it. Okay, let's say temp F, and I know my code has become very small. And please let me know if you can see the live code again. Okay, so I'm going to assign, or let's say temp. Okay, temp F is fine. Okay, I'm just going to go from 0 to 100 like this. Okay, so now temp F has all the values between 0 and 100, and temp C is going to be, I'm going to apply this, because of the fraction there, it's not going to be a, okay, Leonard, thank you. It's not going to be a linear relationship, I believe. Temp f minus 32, okay, we can put it in parentheses, divided by 1.8, like this. Okay, so let's do a quick plot. And the plot is going to be on the x-axis, we're going to have temp f. On the y-axis, we're going to have temp c. And the type is going to be line. Okay. Okay, margin too large because it was... Oh, it's a linear relationship. My bad. Okay. Yeah, I saw the fraction. Oh, yeah. It's just a fraction by a constant, basically. Okay. My bad. Just forget everything I said. So it is a linear relationship. So you can just multiply it by 0.55. Yes. So that works as well. Okay. All right. So this is how the data is calculated. Let me just make this small. Okay. Well, it's saying that it can't, display it anymore. So I can just remove it if we don't like to see errors like this. Okay. Hey guys, data visualization is coming up very soon. It's going to be very fun. We're going to visualize data. All right. So, all right, everything is done. E3. Which weather station has the lowest average humidity when it is windy? Okay. All right, let's do this. So this would be E3. Now the first one was E1 and E2. Okay, we want it when it is windy. Okay, so this is specified. So we can filter, and windy status has to be this has to be weather extended, by the way. Okay, so the windy status has to be equals windy, right? So this is going to focus on the windy data only. And by that, after that, we can go ahead and just summarize, because we just want, we said which weather station. So we need to group by origin, because we want it for each weather station. So we group by origin. Okay, we group by origin, and then after that, we can summarize. Okay, we can call it AVG temp. Okay. Okay, let me just do it in Celsius. That's why I added underscore C. You can name it whatever you want, as you know. So mean temp C na.rm equals true. Okay, and we were looking for the lowest. Okay, so there are only 3 values, so I can basically look at it. But if we didn't have only 3 values, then I would need to arrange to kind of have the one that I'm looking for on top, and that would be LaGuardia. Even though, as you can see, the difference between the temperatures is not really big. Okay, so that's it for E3. What is the most common combination of windy and cold statuses? Okay, for example, the different combinations are windy and cold, windy and not cold, not windy and cold, and not windy and not cold, I think. Okay, so these are the 4 combinations. So we want to find out what is the combination of these weather conditions that you will experience the most, okay, in all of these places. So we don't want it for a specific place, but for all places, and that is E4. Now, I'm sure that many of you may have struggled with this, and I understand why. So that's not really a problem. You're going to see how to do this. So we use weather extended. Now for this one, you need to group by 2 things. The first thing is you need to group by cold status and windy status. Okay, so you have one group here, you have one group there, and you have basically some sort of cross interactions because you group by both of them. Now, after grouping by both of them, you can now count them. Okay, I'm just going to call it N instead of count like we did last time. Okay, now, actually, as far as windy status is concerned, and even cold status, we have some NAs, as you can see. And the NAs come from the fact that when we were, creating the cold status and the windy status over here, okay, some of these columns did not have any data. So the temperature is not recorded everywhere, you know. Also, the wind speed is not recorded everywhere. So for the places where temperature is NA, cold status is going to be NA as well, even as you create it like that. Okay. In the same way, for the places where wind speed is NA, okay, windy status is going to be NA as well. Okay, I'm checking. Okay, so Leonard, you shared your code. Okay. So you're basically sharing what you did. Okay, that's perfect. That's perfect. Okay, great. And Romina is actually giving you a good advice. If you have some as.numeric, okay, Romina, I'm not sure who you were talking to. I'm actually looking at this code and I'm not seeing any as.numeric anywhere. Okay, or maybe you're just giving the advice to everybody. Okay, if that's the case, then that's wonderful. Okay. All right, so guys, you see, in all the data sets, you see the data set is the weather data set is actually an hourly type of data set. Let me actually show it to you. So this is an hour by hour kind of data set, and it starts at 6 a.m. On January 1st. Okay, 7 a.m. and 8 a.m. Okay, and then it goes all the way to December 31st. Okay, so over here, oh, that's what I just did. It shows you all the different combinations of cold status and windy status together. So as you can see, it was cold and not windy according to my thresholds about 11,384 times. Okay, and actually let me go ahead and arrange, because we're looking, oh, that's not the pipe operator. Okay, arrange descending n. Okay. Alright, so that's cold and not windy. So it happened 11,384 times. And cold and windy 11,277 times. Okay, and so on and so forth. Not cold and windy, not cold and not windy, and all that. So in that area, if I live there, because I have my own threshold, so if I live in that area, I need to be, you know, fine with cold and not windy, because I am going to experience it a lot more than other conditions. But of course, as you can see, cold and windy is up there too. And guys, this is not a good combination at all. Cold and windy, you know. Like if you've been to Chicago or a place like that, you know, it's not the best. Okay, so that's E4. Guys, I hope you can see how much power you have in your hands right now, or in your heads, I should say. Okay, these functions, you know, you can use them to do a whole lot of things. Okay, let's continue, guys. Let's continue. So that was E4. What is the most common combination of wind and cold statuses? E5. Which weather station between JFK and EW has the highest average wind gust in the summer months? And we assume that it's from June to August. Okay, so we can do that. E5. So number one, we want to keep only two stations. We only want JFK and EWR, so LaGuardia is out, right? So we can filter. There are two ways of doing this. You can do origin in JFK. I hope you remember this, guys, even though we haven't used it too often. Okay, but this is how you do it. So you can do this. Okay, so it's going to keep LaGuardia. It's going to keep JFK or LaGuardia. Or you can do this. So I'm going to turn this into a comment. Or you can do this. Filter origin, because we know that there are three, and there's one of them that you don't want, right? So you can write it like this: different from LaGuardia. Okay, and if you do this, you're going to get exactly the same result. I mean, previously we had what, 17,409, and here you have the same 17,409. Okay, so you do whatever you feel like doing. Okay, I personally prefer this because I like to be more expressive. I like to show what I want. Okay, now in some cases you may want to show what you don't want. So hey, if that's what you want to show, then the second option there is what you want to use. Okay, so we want to find out for these two places the highest average wind gust in the summer months. So we're not done filtering actually. So after this, the month has to be summer month. So this has to be in, or I can just say greater than or equal to, June is the 6th month, right? June to August. Okay, June is the 6th month. Okay, and I can add month less than or equal to, August is the 8th month. I can do this. Or I can just add the in as well, you know, that'll be perfect. Okay, so let me run this. Okay, so now it's, you know, brought everything down to about 4,403. And average wind gust in the summer month. So which weather station? So we need it for each of the weather stations. So we need to group by origin, because we want the summary statistic to be for each of them. Okay. And that would be, let's call it AVG wind gust for average wind gust, and that's the mean wind gust. Okay, NA.rm equals true. Okay. And we want the highest, right? So there are two of them, is JFK. And just because I need to be a perfectionist, since I'm teaching you guys, let me just do a range on AVG wind gust. Okay. Alright, so that's JFK, as you can see. Alright, so now the last stretch. Oh, okay, I didn't realize that we were going to take so much time, but it's all worth it. So if we want to keep within the same time, you know, the same sort of duration of the streams, I think that after this we'll have to call it a day, and then whatever else I had prepared, maybe we're going to do it on Tuesday. But this is really good because we are kind of learning how these things are working. This is very valuable, guys, very, very valuable. So let's keep doing it. Just a second. Okay, so let's go to the F part now. Now is the stream still going? Okay, so okay, Leonard says that is okay in the Slack channel. Okay, that's great. Okay, so let's continue with F. I hope Romina is here and everybody else. Hope everybody's here. Okay, Romina is here. And I know there are some people who are online, and I guess maybe they are shy to say anything in the chat because there are usually more people online than what I see, like the number of people in the chat. But I hope that you guys too are able to see me right now. Okay, so let's look at the F now. You know, part F. A very influential business guru recently moved to New York City and hired your services as a data scientist in order to help him or her make smart choices for his or her frequent trips. Okay. Now the first thing here is copy the code, copy and paste the code that you previously wrote for this, you know, airtime, distance, departure, delay, arrival delay, scheduled airtime, or scheduled airtime, you know, time made up and things like that. Now there's something very quick that I'm going to say here. Actually, Leonard, I don't know if you remember when we were looking for the very first time at airtime made up, you realized that there were some issues because you thought and or you realized that, you see, the values for the airtime made up was, you know, unusually high, and they were, you know, very high, and we couldn't really figure out what was the problem. And I said that I was going to check the data to see if there was a problem. So I don't know if you remember that. And indeed, there was a slight issue. Okay, I wanted to copy and paste the code, but I think it would be better for me to write it so that you guys can see what I mean. Or maybe I can just explain that part only. Alright, so now we're going to use the flights dataset, and we're going to mutate. Actually, the next data manipulation function I want to show you is the select function, but we're not going to do it today, even though I am going to use it now just for the sake of explanation. because there are many columns here which are not needed for what I want to show you right now. So this code is just to explain the problem that Leonard actually pointed out. Okay, so we're going to use the select function because we want to select some specific values, and we basically want values that contain the word time. So when we do that, we have departure time, scheduled departure time, arrival time, scheduled arrival time, and air time. Okay, and these are the colors that we need basically. This is a very useful function. We're going to learn about it. Okay, now let's compute this. Let's compute departure delay. Okay, departure delay. We said that the departure delay is the actual departure time minus the scheduled departure time. Okay, all right, now check this out. Without doing the as numeric and dividing it by 60 because we want it in minutes and all that, see, what you get there is a value in seconds, and because we wanted it in minutes, that's why we divided it by 60. Then one other thing that we did is we decided to compute the scheduled airtime. So the scheduled airtime is how long was the time is every flight scheduled to take. Okay, so scheduled airtime, and of course we said that this is the scheduled arrival time. So the arrival time that is scheduled minus the departure time that was scheduled, like this. Now, this is something that I did not know. So it's in my research that I kind of found it out. You see, departure time minus scheduled departure time. This is departure time. This is scheduled departure time. They are both of the same class, DTTM. Okay, and the result is in seconds. Now, scheduled arrival time and scheduled departure time are still of the same class, DTTM, which stands for date time. But when you look at when you calculate the difference between them, what you get is in minutes. So there's some kind of inconsistency because one is in seconds, the other one is in minutes. And actually, when I taught you this, we kind of blindly divided it by, like, we turned it into numeric values with the as.numeric function, and then we divided it by 60. Okay, and we divided it by 60. As though these values were in seconds, but they are not, as you can see. So upon digging deeper, I realized that, you see, when you're using the minus sign with datetime data, okay, basically there's another function that is called, and that function is the difftime function. Okay, and by default, what the difftime function does is it will look at the kind of, when you look at the difference between two values, it will, kind of estimate if these values are very big or are very small, and then it will take an appropriate measure of time to display your data, okay, or to give you a feedback of your data. Now, because the departure delays are usually quite small, 2 minutes, 3 minutes, 10 minutes, it gives it to you in seconds. But when it comes to the difference between, scheduled departure time and scheduled arrival time, sometimes it's big. Like, you see, this is like very early flights in 2013. So because they are very big, these would be very big in seconds. So that's why it just gives it to you in minutes. Okay. So how do we avoid that? The best way to avoid it is actually to use the difftime function itself and to specify the kind of units that you want to use. Okay, so guys, if you look at my solutions, this is what I use there. So instead of doing departure time minus scheduled departure time, I'm going to use difftime, which is difference in time. Okay, and of course the data that you use inside difftime has to be date time data. Okay, if it's not date time data, it's not really going to work. So departure delay was departure time minus scheduled departure time. So the first one is going to be departure time, comma, the second time is going to be scheduled departure time. Okay, so you want to look at the difference between departure time and scheduled departure time. And there's another argument there for the time, okay, the measurement of time that you want to use, the unit of time, and we want it in minutes. If you want it in minutes, you can just write mins like this, and it's text, so M-I-N-S. All right. So then you are sure that you have control over the your units that is produced there. Okay. All right. So I'm going to do it here again. Diff time, and this is scheduled arrival time, scheduled departure time, units plus minutes, like this. So you see, now everything is in minutes. Okay. And after doing that, now that we know that everything has the same units, okay, we can then decide to convert it into numeric values by wrapping everything around numeric if we want to, like adding a as.numeric here, and right before the comma adding another one there. Okay, so let me just run this one. Ooh, it's not supposed to be like this. Oh, okay, no, it just didn't come out. My bad. Okay, so you see, now we have double. Okay, and these are usually the kinds of values that we're expecting anyways. Okay, you can actually do it for the second one. Actually, let me use the pipe operator for this one, for the second one, just so you see other ways it can be used. I don't know if you remember the theory. Okay, guys, do you still have the link to the live code? Can you please give it to McNamara? All right, so I hope you remember the theory behind the pipe operator. I told you that whatever comes before a pipe operator, it takes it and it puts it as the first argument of the function after the pipe. Now, in as.numeric, there's only one argument, whatever you want to turn into numeric. So after this, you can actually add pipe as.numeric empty. So basically, this pipe is going to take the diff time, the difference in time that you calculate here, and it's going to put it right into the as.numeric. So this is something that you may want to do if you don't want to just use as.numeric to wrap everything. Okay, so I'm just leaving it there just so that you guys can see other ways of using it. Thank you so much, Romina. Okay, so now we have everything in minutes, which is cool. Okay, which is cool. Okay, so I just wanted to show this to you guys. So let me go ahead and now copy the entire code. Okay, so now I have everything there, and you see now I'm using diff time instead of just using a minus like this. Okay, and I store everything into flights extended, just like we had weather extended. Okay, now everything is going to be in flights extended. So let me run it. Okay, let's take a look at F2. Compute the average departure delay for each carrier. Okay, Shewang says 1017. Okay, great. I will address this issue later. Alright, compute the average departure delay for each carrier. Which carrier on average is more reliable for flying out of New York City? Okay, so flights extended, because this is the one that has what you call it, the departure delays and stuff like that, and we want the average departure delay. So we need to group by carrier because we want the average departure delay for each carrier, and we're going to summarize. Okay, 1017 for everybody. Okay, I'm going to get back to that, guys. Okay, so flights extended group by carrier, summarize, and let's call it AVG DEP delay. So average departure delay, which is the mean departure delay, NA.rm is equal to true. So for each carrier in the entire year 2013, this is the average departure delay. Okay, so some departure delays were higher than these, some were lower, but for each carrier, this is what they have on average, and we want to find out the one that is the most reliable. Okay, now it would be wrong to do a range, then average departure delay, and pick the lowest in this context, because okay, I guess it works here. Okay, it works in this. Okay, because this is the one that is closest to 0, because in other contexts you would have some that are very minus and some that are very plus. So what you want is the one that is the closest to 0, because a 0 departure delay means that you're going on time. Okay, and in this case, I think this is Hawaii Airways or something like that. they have the closest departure delay to 0. So this one is the most reliable for flying out of New York City on average. Even though everything else is not really that bad on average, 3 minute difference, 5 minute difference is not really important. But if someone was to be given a prize for being on time, that would be the airline that takes you to Hawaii, which makes sense. Guys, I'm not sure you know about it, but Hawaii is extremely far. Even for people living on the West Coast, Hawaii is far. Now let's do a little bit of Google Maps here. I'm sure that if you don't live in the USA, you've heard of Hawaii many times, and you may think that it's like it's easy to access. No, guys, let me show you. This is Hawaii. This is the United States, right? This is Hawaii. So going to Hawaii, man, it's far. So can you imagine, people leaving New York City, and flying all the way to Hawaii. And this is Honolulu. This is where the biggest airport is. Man, this is not an easy thing, So of course they have to be on time. So now you understand why these guys are on time, because they fly over a very long distance. Okay, so let's continue. That would be for F2. Okay, let me just write it here. That would be for F2. Okay, let's do F3. Now we want to find out the most efficient airports. Okay, compute the average departure delay for each airport of origin. Okay, which airport on average is the most efficient? Okay, so basically you can copy and paste this code and change the grouping variable. So you still want average departure delay, but you want it for each airport of origin, right? And now you can see that on average, JFK flights have the lowest average departure delay, okay, on average. So let's just say that, they have the most efficient, even though from a statistical perspective, we need more information, like the standard deviation, for example, that we talked about earlier. We need it in order to make a final decision, Okay, so that's F3. Let's look at F4. Okay. Oh, Chewon, you've been to Honolulu. That's great. It's a beautiful place. From what I've seen on TV and on the internet. Okay, that's great. I'm sure you had a good time in Honolulu. Okay, so the business guru, okay, that guy who hired your services, is planning to make several trips out of New York City, okay, in the months of March, June, and September. Okay, now I'm wondering if we are still live. Guys, are we still live? Okay, great. So, all right, let's continue. Well, we're almost done. This is the last part. Again, I guess I mistimed. Like, I think my plans were off. I thought that I would be able to cover all this and then do other things. But yeah, it's fine. I think we're still learning, how to better use the group by function and summarize and things like that. The business guru is planning to make several trips out of New York City in the months of March, June, and September. He is planning several trips. So I said he and she earlier, and now I'm just saying he. So hey, he or she is planning several trips to Dallas Fort Worth, to Atlanta in June, to Houston in September. So again, Dallas Fort Worth in March, Atlanta in June, and Houston in September. Compute a monthly average departure delay in each airport and recommend an airport of origin for his flights in each of these months. Okay. So if you'd rather, have the business guru as a lady, just say her. Okay. So we've got flights extended here. All right. Now we're not interested in all the months, so we need to do some filtering when it comes to the month. So month needs to be in. Hope you remember this. March is the 3rd month, June is the 6th month, and the last one is September. Okay, June, July, August, September. So that'll be the 9th month, right? Like this. All right. Also, not all destinations. Okay, we have some specific destinations that we are looking for, oops, it has to be in because there are several ones. We want DFW, we want Atlanta, and we want Houston. All right, so now the big data set of 300 over 300,000 rows is now down to 8,227. Okay, so whatever we're going to do is going to be on this. Now for these values, okay, for these months and for these destinations, you want to find out compute a monthly average departure delay in each airport and recommend an airport of origin for his flights in each of these months. Okay, so again, guys, one thing that I would like to say here is, Romina is saying hi here. Okay, that's fine. It really depends on you. You know, you may want to focus on all the flights going to these destinations specifically. Okay, all the flights to these destinations specifically, and calculate the average departure delay. Or you may want to use all flights in the entire airport and then make a recommendation based on all the flights in all these airports in all these months. This is something that you may want to do. But let's just be specific for the sake of this example. But then again, in your context, you may want to do something different. Okay. All right, so after this, we want the monthly average departure delay. So we want the departure delays by month. Okay. And we know that we have this monthly, this month column here. So we can group by month because we want the departure delay for each of these months. So we need to group by month, okay? And we need to group by airport of origin too, because there is some there's some advising to do here, right? About the specific airport to use. Okay. Oh, we're not done. After grouping, we now want to compute the average departure delay. So AVG DEP delay, mean of departure delay, NA.RN equals true. Okay, so you see now we have, for each month, we have the average departure delay for these origins. Oh, actually, no. That's not how we need to go about this. Actually, my bad. Let's see. That's F4, right? Let me see. Okay, it's fine. We can just do this. But yeah, one thing we need to add here would be, if you want to be very specific, is to add the destination too, because for each flight and each month, so you see we group by month, origin, and destination, and then the average departure delay for these specifications. And again, this is not what you might want to do, but let's just be specific like that. So on average, you know, flights, you know, linking EWR and Atlanta in March, okay, have this average departure delay, okay? Now the flights from EWR, DFW in March, this is the average departure delay, and so on and so forth, okay? Now let's take a quick look again at what the businessman is doing. So he's going to Dallas in March. So for the March flights, I'm just going to give it a name. Let me just call it monthly average departure delays, like this, okay? The name is fairly long, but let's just call it like that. Okay, seems like we're having some issues. The internet is dropping again. Okay, great. Thank you for letting me know. So before the internet dropped, I was saying that we just need to look at the different flights now. According to F4, in March, he's trying to go to Dallas. So I just gave it this name. Okay, so let me just copy it. All right, so we're going to filter month equals 3. That's going to be for the Dallas trip. So in March, we want the lowest average departure delay. Okay. So in March, okay, I think we're supposed to recommend airport of origin for F4. Yes. So JFK is the airport you would recommend, because going to Atlanta in March, okay, they have an average departure delay of 4.38 minutes. Okay, for the Atlanta flight. Now for LaGuardia, it's about 9 minutes. And actually, we may want to do March and destination Atlanta, so that we have the data of interest only. Okay, so you see clearly that JFK is really where you want that businessman who hired your services. This is like your consulting services. You're going to tell him, hey, you know what? In March for your Atlanta trips, I would like you to take your flight out of JFK, and you show him or her the data for it. Okay, then in June we have flights to. Oh, sorry. In March it's actually DFW. I'm sorry. It's Dallas in March, not Atlanta. It's still JFK. Okay, it's still JFK for DFW in March. But in June now we have Atlanta. So this now is going to work. This code here, okay, and on average 14.6 minutes of average departure delay, okay, and that would be LaGuardia, okay, not JFK. That would be LaGuardia for this one. Okay, and the last flight is going to be Houston in September. Okay, so I'm just going to copy and paste. Oh, okay. Okay, that's the 9-month, and Houston IAH like this, and LaGuardia again. So LaGuardia in June, JFK in March, and LaGuardia in September. Okay, so this is, again, these are consulting services, and you're going to be paid big money to give this guy this kind, or this lady, these data-based decisions that he or she might want to make. Okay, guys, we have 3 more questions, and then that'll be it. Okay, compute the daily average departure delay. What was the longest departure delay in the year 2013? Make some research on the internet to find out the probable reason for that. Okay, is my internet still dropping? Well, I'm seeing it should be working right now, so I'm not really sure. But please, you guys, let me know if you can see me. Yeah. Anyways, I hope you'll be able to see this. If you can't, I'm just going to write it in the Slack channel. The video is being recorded anyways, whether the stream is working or not. So let me go ahead and just record the video, or keep doing what I've been doing as though the stream was working, and you'll be able to watch the last part of the stream for these questions that I'm going to solve right now. So let me write it in the chat, and then I'm going to do it. Okay, so the question here is compute the daily average departure delay. What was the longest departure delay in the year 2013? Make some research on the internet to find out the probable reason for that very long average delay. Okay, so taking a look at the flights data set, okay, you want it to be daily. Oh, okay, so you're saying it's smooth. Okay, well, I'm glad to hear that. Okay, great. Okay, so we want it to be daily, right? We want daily data, or daily averages. So we need to be able to group the variables such that we can capture each day. Now, you might be tempted to do this. Flights group by day, like this. Okay, then summarize average departure delay, like we've been doing, equals mean departure delay na.rm equals true. You might be tempted to do this. It's actually flights extended because there's no departure delay in the original flights data set. Okay, you might be tempted to do this, but if you do, then you're going to get into a problem. You see, you will end up having 31 values only. So why is that? Why do we get 31 values and we don't get 365 values? The reason for it is because when you look at the flights data set, okay, or flights extended, I mean, what I want to show you is in both. These days, you know, you have 1 through 31, and then it comes back 1 through 30 or 28 because it's February, then it comes back 1 through 31 and so on and so forth. So when you group by day, it will take all the ones together, you know, all the ones in this column together, and all the twos together, irrespective of month and stuff like that. It will take all the ones together. So the result of this code that you see here, this right here, this is the meaning. It is the average departure delay of all first day of the month throughout 2013. And this is the average delay for all seconds of the month throughout 2013. And so on and so forth, okay, overall. But that's not really what you want, okay, because you want each day in each month, okay, because you want each day in each month, you also need to group by month, okay. So when you group by month and day, now you have for the month of January and the first day, so that's one day here, right? You get this average departure delay. And you get this average departure delay for, this is January 2nd, January 3rd, and so on and so forth. And you can see that there are 365 values, which we were expecting. Okay, so you're trying to find out what's the highest average departure delay, okay? And because we wanted it daily, right? So now we can arrange descending order average departure delay like this. And this is 68.9. In other words, on average on that day, which is March 8th, okay? On that day, there was an average delay of over an hour. So some delays were more than that, others were less than that. But on average, we had a delay of over an hour, which is kind of, you know, surprising, you know, on average, you know. So I asked you to go to the internet. This was because of heavy snow. I looked at Google and I found, you know, a sort of article, you know, there was heavy snow on that day. So many of the planes were grounded for some time. Okay, guys, we're almost there. F6. Oh. On average, which carriers fly the slowest to Houston in February or April? Okay, on average, which carriers fly the slowest? All right, so flights extended. Okay, and we want the flight to Houston. Oh, sorry, it's filter, not flight. Okay, and we want the destination to be Houston. Okay, so that's what we got for now. And we want it to be in February or April. So we have month in February or April. Okay, so that's the data we want to do our analysis on, or our manipulation, I guess. All right, so we want it by carrier. So group by carrier, you want the average speed of travel. Okay, and I think we had one for in kilometers per hour or something like that, right? Okay, that's average speed in kilometers per hour. Yes, and that's the average speed in miles per hour. Okay, over here. So we can use whatever we want. I'm actually going to repeat it here. So let's do kilometers per hour. And this is equal to the average of, oh, that's not means, but mean. Okay, no. Oh, I'm trying to, okay. Oh yeah, so you saw there were some NAs there. NAs are the staple of big data sets. Okay, so we want those who fly the slowest. You know, based on this, you can basically say that there are only two carriers that flew from New York City to Houston in the months of February and April. Is it a general thing? I'm not sure, but this is what we can see in the data, right? And because we want the people that fly the slowest, we're going to arrange AVG speed KMH. Okay, and that would be American Airlines on average. Okay. F7. For F7, which carrier has pilots who care the most about making up time in the flights when there is departure delay? Okay, so if there's departure delay, do you see that pilots are trying to make up time? And if that is the case, which carrier has the pilots that do it the most? Okay, and again, all these questions, these are questions that you may want to tell that business guru that is going to fly out of New York City a lot. So flights extended. Now, one of the conditions is that there is departure delay. So I'm sure that many of you have been able to see this, but we need to filter such that the departure delay is strictly greater than 0, because if there's no departure delay, then you can really call it time made up. So we just want to analyze those cases when there's a departure delay. Okay, so now that we have that, you want to summarize by carrier, group by carrier, because group by carrier, that summary statistic that we're going to calculate, we want it for each carrier, so we need to group by carrier and then summarize. My bad. And let's call it average time made up. It's pretty long. You may want to write something smaller. It's really up to you. And let's look at the average time made up. Let's remove the NA values. Okay, and who cares the most? So that airtime made up, we want to arrange and we want to get the highest value. Average airtime made up. Okay, now guys, can you imagine, on average, you have some carriers, you know, that actually, you know, even with a delay, okay, even with a delay, they actually fly such that they take more time than the scheduled airtime. Okay, but yeah, whatever this carrier is, YV, I'm sorry, these people, they make up a lot of time whenever there's a delay. So on average, you see 37.9 minutes of time made up. That's pretty impressive. Okay. Well, guys, again, we had a tornado come through my area 2 days ago. So thank God it didn't really affect my city that much, but surrounding cities were affected. And this actually affected some of my students. You know, they had trees fall on their houses and things like that. So this is really why the network is really playing tricks on us. But guys, I mean, we spent an hour and 30 minutes. Okay, usually we spend about an hour and 15 or a little more. So it's not too much more than, you know, what we've been doing usually. But I really wanted to take the time to go over these practice questions with you. Because understanding how group by and all these things work is extremely important. So please, guys, let me know if everything went well for you. Of course, plenty went, you know, awful today because of the internet connection. But you will have the recording for the past that you've not been able to see, you know, to follow. You will have the recording. Okay, so let's continue our discussion on Slack. You know, if you have questions and whatnot, please be sure to let me know in the chat, or on Slack, I should say, and let's you know, continue everything there. Let's keep learning. All right, guys. So this was me. You take care, guys, and I will see you Tuesday. And God bless.